Welcome, class, to the Intro to Java Programming. In this lesson, we'll review abstraction, one of the major building blocks to object-oriented programming, along with how it works with the abstract class, accessibility, and some code examples. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks of object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we'll focus on abstraction with the abstract class. Abstraction means using simple things to represent complex things. Abstraction is a process where you show only relevant data and hide unnecessary details of an object from the user. Yes, this definition is a little vague until you better understand the true meaning. Let's start with an example that covers an overview. Abstraction is the use of simple things to represent complex things. My favorite example is the remote control for a television. The power on, power off button is simple to use. Behind the scenes, there's a complex communication process between the remote control and the television that turns the device on or off. How the remote control actually works is abstracted away or hidden. Simply clicking the button is the only thing you need to know. Abstraction can be achieved with an abstract class or an interface. This lesson will cover the abstract class. The abstract class works much like inheritance of a class. An abstract class and a child class are connected together in a parent-child relationship. These two classes can be called the superclass and the subclass. The superclass is the class being inherited from. It is often referred to as the parent class or the base class. The subclass is the class that inherits from the superclass. It is often referred to as the child class or the derived class. When declaring the abstract class, there's a class name like monster and a keyword abstract. When declaring the child class, there's a class name like goblin, and the keyword extends is used to inherit the abstract monster class. The keyword extends works for inheritance and the abstract class. Both classes should follow all the rules of encapsulation. The parent class could have private constructors, properties, and methods, and the parent class can have public constructors, properties, and methods. Inside the parent class, all methods can access public and private properties, methods of the parent class. The child class can have private constructors, properties, and methods, and the child class can have public constructors, properties, and methods. Inside the child class, all methods can access public and private properties and methods of the child class. The child class can access all the public constructors, properties, and methods of the parent class. The parent cannot access any constructor, property, or method of the child class. If the parent class has a required constructor, the child constructor can call the parent with the keyword super. The parent constructor call must be the first line in the child constructor. Let's imagine there's a game control class that can instantiate the goblin child class. It can access all the public properties and methods of the goblin child class. And it can access all the public properties and methods of the abstract monster parent class. Correct. It is encouraged to avoid the use of public properties. However, if there were public properties, the game control class would have access to those values. One common purpose of the parent class is code reusability. Remember, one of our goals for object-oriented programming is reusability or dry. Don't repeat yourself. Inheriting an abstract class that has code we need is one way to reuse existing functionality. It is common for several classes to inherit the abstract parent class and utilize existing code. For example, let's say the parent class has a public method called isSleeping. All monsters will have a 10% chance of being asleep. Let's say the result is false for this example. When the game control class instantiates the goblin child class and calls the isSleeping method, the value false is returned. If the game control class instantiates the skeleton child class, which also inherits the abstract monster class, and calls the isSleeping method, the value false is returned. The same method from the abstract monster parent class is used by both child classes. This is one example of code reusability. Another example of code reusability is an abstract monster parent class called getMonsterName. For this method, the value default monster is returned. When the game control class calls the goblin child class for getMonsterName, the value default monster is returned. Each child class can override a parent method to perform custom behavior like returning a unique name. Inside the child class, create the same method name and signature. Above the signature, enter an annotation @override. This annotation is not required but very helpful to other developers as a clue the method is overriding a method from the parent class. Inside the code block, let's return Goblin. Now, when game control calls child.getMonsterName, the value Goblin is returned. The skeleton class could override the getMonsterName method and return skeleton. There are a couple of noteworthy differences between inheritance of a class and an abstract class. An abstract class cannot be instantiated by itself. This command is not allowed. Another difference is the abstract class is allowed to have an abstract method which is a signature only, no code block. The child must implement the abstract method. Implement means the class must contain a specific method and the code block must be written. Once the class implements all the abstract methods, it is considered to be a concrete class and can be instantiated. From the previous example, there's no point having a getMonsterName method in the parent class if the child will override the method. GetMonsterName should be an abstract method. Place the keyword abstract before the data type and method name. The game control class has no access to the abstract method in the monster parent class. The child class is required to implement all abstract methods before instantiation. The keyword @override is not required but encouraged. The end result is the same. The Goblin child class will return Goblin, the Skeleton class will return Skeleton, and the Dragon class will return Dragon. Please note, a non-abstract class cannot have abstract methods. Let's look at the code for the abstract class. Open the OOP intro project in IntelliJ, close any open class tabs. Let's create a new test package called Abstraction. Let's create a new test class called Monster Abstract Test. This test will prove you cannot instantiate an abstract class. Let's create another test class called Goblin Abstract Test. This first test will check the public and private properties available to the parent class. A new Goblin Abstract object is instantiated as the variable name parent. Please note that the data type is a monster abstract class. The value from the parent public string is stored in a variable called actual. The next line asserts the value matches the expected result. This line holds the value from the parent private string. There is no test because we know this line will generate an error. Private properties cannot be accessed. The parent class is not allowed to access public or private properties of the child class. These two lines will generate an error. This test will check the public and private properties available to the child class. A new Goblin Abstract object is instantiated as the variable named child. Please note that the data type is a Goblin Abstract class. The value from the parent public string is stored in a variable called actual. The next line asserts the value matches the expected result. On this line, with the use of casting, the parent public string can be stored in a variable called actual, and this line will assert the value matches the expected result. Casting the parent property is redundant and not needed. The child class can see the parent public properties. Casting is not required. The child class is not allowed to access private properties of the parent class. This line will generate an error. The value from the child public string is stored in a variable called actual. The next line asserts the value matches the expected result. The child class is not allowed to access private properties of the child class. This line will generate an error. This test is very similar to the parent property test, except it will show public and private methods available to the parent class. A new Goblin Abstract object is instantiated as the variable name parent as the data type monster abstract class. We will prove the parent class public methods are available. The parent class private method is not accessible. The parent class is not allowed to access public methods from the child class unless casting is used. And the parent class is not allowed to access child class private methods, even with casting. This final test is very similar to the child property test, except it will show public and private methods available to the child class. A new Goblin Abstract object is instantiated as the variable name child as the data type Goblin Abstract class. We will prove the parent class public methods are accessible. Casting the parent public method is not required. We will prove the child class public methods are accessible, and the child class private methods are not accessible. Let's create a new Java package called Abstraction. Let's create a new class called Monster Abstract. This is the parent class. Add the keyword abstract between public and class to make this an abstract class. There are 3 properties, 1 private and 2 public. This is a constructor used to set the monster name. This is an abstract method that must be implemented by the child class. These are the public getter and setter methods for the private property. These are 2 other methods, 1 public and 1 private. Let's create the child class next inside the abstraction package. Call the class Goblin Abstract. In the class declaration, use the keyword extends to inherit from the monster abstract class. There are 2 properties, 1 private and 1 public. This is a constructor used to set the monster name property. Super will call the constructor of the parent class and pass the monster name. Super must be the first line of the child constructor. Other child class constructor lines will follow. This method will implement and override the parent abstract method. This method will override the parent class. These are 2 other methods, 1 public, 1 private. This method proves all the public and private properties and methods from the child class are available. These are the child methods. Notice there are no compiler errors. These are the child properties. Again, notice there are no compiler errors. From the parent class, only the public properties and methods are available. The private properties and methods are not available from the parent class. The value from the overridden child class is stored here. The value from the parent is explicitly requested and stored here. And overriding a private method from the parent class is not allowed. Let's go back to the monster abstract test class. Notice there's a compiler error. This proves you cannot instantiated abstract class. Let's comment this line out. Let's go back to the Goblin abstract test class. There are several compiler errors, all of them prove accessibility issues with the parent and child class, as noted before. This test will verify the parent object variable cannot access parent private properties or any child public and private properties. These 3 lines will prove access is not allowed. Let's comment these 3 lines out. This test will verify the child object variable cannot access private properties of the parent and child class. These 2 lines prove access is not allowed. Let's comment these lines out. This test will verify the parent object variable cannot access parent private methods or any child public and private methods. These 3 lines prove access is not allowed. Let's comment these lines out. And this test will verify the child object variable cannot access private methods of the child class. This 1 line proves access is not allowed. In the Goblin abstract class, comment out these lines. Let's run these tests to prove property and method accessibility. This test passes. This test passes. This test passes. And this test passes. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of abstraction with an abstract class. 2 classes are connected together in a parent-child relationship with the keyword extends. Both classes should follow all the rules of encapsulation. Accessibility for each class was covered. One common purpose of the abstract parent class is to hold reusable code and possibly force a child class to implement specific methods. In the next lesson, we will discuss abstraction with the interface. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!